Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very nice equation with complex numbers. So we have an equation z squared equals z bar. As you know, if you don't know complex numbers, go ahead and check out the lecture videos. I start with the very basics of complex numbers, and we have this equation where z squared is equal to z bar, where z bar is the complex conjugate of z. In other words, if z is equal to a plus bi, then z bar is a minus bi. Okay, so what is so special about z bar or complex conjugates? Well, when you add z and z bar, you get a real number because a and b are real, remember? A and B are real numbers. And when you multiply z and z bar, you get a squared plus b squared, which is sum of two squares, which is also real. So you get two real values by addition and multiplication, and that's the only time you're going to get these values. So it's very, very special. And if you are dividing two complex numbers, we use conjugates, and in so many other situations we do use them. But this time it came up on one side of the equation. So how do we handle something like this? First of all, I'm going to experiment with something that I haven't tried before, hoping that this is going to give me something helpful. And then I'll proceed with the solution that I planned. So since z times z bar is something special, I think it makes sense to multiply both sides by z. Of course, we kind of need to assume that z does not equal 0, but you also have to think about it this way. Can z be equal to 0? What is the conjugate of 0, right? 0 plus 0i. If you think about it, it's conjugate is itself, right? 0 minus 0i is the same thing as 0. So they're both 0. So z equals 0 seems to work in this case. But now let's assume z does not equal 0. We could also divide both sides by 0. I don't know if it's going to help at all, but let's just multiply first. If you multiply both sides by z, you're going to get z squared times z is equal to z bar times z. And then z squared times z is just going to give you z cubed, which is z to the third power. And then z bar times z. Now, what do you get from here? You get the sum of two squares, but what is so special about it, right? But think about the definition of absolute value. What is the absolute value of a plus bi? It is the square root of a squared plus b squared, right? If z is given as a plus bi from here. So this is just that number squared, because if you multiply these two, you get a squared plus b squared, which happens to be absolute value of z squared. So in other words, z bar times z can be replaced with absolute value of z squared. Now, does this help at all? We have z cubed equals the absolute value of z squared. Could we divide both sides by z? Is that going to help? Or could we divide by absolute value of z? I'm not sure how that's going to work. You could take the absolute value of both sides. I'm not again sure if that's going to help, but I got to this point, and the rest is left as an exercise for the audience. Anyways, so let's go ahead and proceed with the method that is very typical for these kinds of problems. So z squared equals z bar. Since z is a complex number, it can be written in standard form or rectangular form. So what is the rectangular form? It is z equals a plus bi. Does that look familiar? It's also the name of the channel. Hopefully that's familiar to you. Now let's go ahead and plug this in. But what is z bar? Well, easy. Z bar is just a minus bi. So let's go ahead and plug it in. Replace z with a plus bi and then square it. And then replace z bar with a minus bi, and now you got yourself an equation. Let's go ahead and solve it. See if we can solve this equation and find a and b. Remember, a and b are real numbers. They're not complex or imaginary. Okay? So they are complex because they are real, but you know what I'm talking about. A squared minus b squared plus 2abi. So get used to squaring a plus bi. It's kind of similar to a plus b, but with a little twist with a minus sign in it. And that's equal to a minus bi. Now, you can combine these two things and set it equal to 0 if you want, or just compare the real parts to real parts and imaginary parts to imaginary parts. I'm going to do the latter. Is that the second one? Former is the first, I think. This is going to be the same thing as A, and this is going to be the same thing as negative B. Now, let's go ahead and write it down as a system of equations. I get two equations from here, and here's my system. Now, when I look at a system like this, I'm definitely going to go for the second equation because that looks a lot simpler and it's factorable. Let's put negative b on the right, I mean on the left, you know what I'm talking about, and then factor out a b, and boom, this gives us two things. Great, awesome. That's why I went for the second equation. From here we can say either b is 0 or a is negative 1/2. You always got to remember a and b are real numbers. Now, why do I keep saying that? Because you'll see in a little bit, sometimes one of these values gives us a non-real value and we have to discard it. So if b is equal to 0, let's go ahead and plug it into the first equation. A squared equals a is what we get from here, which means a squared minus a is equal to 0. Do not cancel out the a's because you're going to lose some solutions. And then factor out a, and you get a equals 0 or a equals 1. It kind of branches off like that, right? So let's go ahead and take a look at these values. For now, let's just go ahead and box them, and then we'll take a look at it later. And from the second piece, a equals negative 1/2, we can definitely plug this into the first equation, which is right here. And if we do, we get 1/4 minus b squared equals a, which is negative 1/2. And if you kind of put the negative b squared on the right and negative 1/2 on the left, we get b squared is equal to 3/4. And from here, we're supposed to get 2b or not to be values. Well, I did it again. B is equal to square root of 3/2, or b is equal to negative root 3/2. Again, let's go ahead and box all of these results, and then we're going to talk about it. So where does this come from? From a equals negative 1/2. So what is all that supposed to mean? Well, depending on the a or b value, we get different values for the other variables. So for example, if b is 0, a is 0. So 0, 0 is a solution, looks like, at least for now. 1, 0 is another solution. I'm kind of writing these as a, b ordered pairs. And the a equals negative 1/2 gives us negative 1/2 and root 3/2, and negative 1/2 and negative root 3/2. By the way, doesn't this kind of remind you sine and cosine of some angle, right? Because look at the values. They should be familiar to you, right? If you've done a little bit of trigonometry, of course. Hopefully you did. Okay, so those are my ordered pairs, and this should give me the z values. Let's go ahead and take a look. This gives us 0, which we already talked about. I think it satisfies the original equation, doesn't it? So this should be good. Z equals 0 is a solution. The second one gives me 1 plus 0i, I'm sorry. That means z equals 1. Of course, z equals 1 works because if you think about the original equation, it was z squared equals z bar. And if you plug it in, 1 squared is 1. 1 bar is 1 because it's a real number. Its conjugate is itself. So it's working. Okay, what about this one? Z is equal to negative 1/2 plus root 3/2i, and z equals negative 1/2 minus root 3/2i. I have a feeling if the first one works, the second one will also work. So these are all good. I don't know, that's not a solution. But now let's go ahead and check these. And I'll probably go with the first one first, because if the first one works, the second one will probably also work. Okay, let's go ahead and check this against our equation. Z squared equals z bar. I don't know why I wrote absolute value. Okay, I'm stuck on absolute value, so this is my equation. What is z squared, right? Let's go ahead and square this. Negative 1/2 plus root 3/2i. If you square it, you're going to get the first number squared minus 2ab is going to give us, let's see, one of the 2's is going to cancel out, and we're going to end up with root 3/2i, I think, right? 2 times 1/2 is 1. And then finally minus root 3/2 squared. That's going to be 3/4. I squared is negative 1, so that's going to be negative 3/4. 1/4 minus 3/4 is negative 2/4, which is negative 1/2, minus root 3/2i. So remember, this is z squared, but it's supposed to equal z bar, and it is. Because if this is z, then this is definitely z bar. And yes, it works. Wow, I'm surprised. I didn't check this before. I didn't do this problem before. So, but I'm pretty surprised to find out that it works. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.